when we talk about an enterprise adopting Gen AI, right? The enterprise has to has to take into consideration the infrastructure, how they set up their infrastructure for doing this. Right? So there are basically three aspects of this, or three layers of this, that an enterprise should look at. So one is that they need to look at the middleware layer. So where the middleware layer actually abstracts the complexity to handle the data flow, and then integrates with your external APIs or your databases, etc. So in a way, you're trying to decouple the Gen AI capabilities with the core system capabilities. So that is what is the middleware, right? And not only that, you will probably want to have interfaces with multiple LLMs, multiple models, and use them for different scenarios, right? And then you have the AI orchestration layer, which is basically the layer where you're creating an agent, and then you are able to trigger an agent based on certain systems, and then take the output of that agent and do something with it, right? So this requires us to, it allows us to use this middleware layer to interface with the AI agents, and the scenarios under which different AI agents are called or invoked is what the AI orchestration layer is all about, right? And so you can also with a good AI orchestration layer, ideally you should be able to do multiple LLMs or multiple AI agents parallelly, and wait for their results, and then take a decision, for example, right? So you can do many things in parallel, or you can do it in series, or you can do it one after the other, and things like that, right? So an AI orchestration layer needs to have all these features. And you can also switch between large LLMs. You can switch between a smaller language model, or switch between different LLMs based on the costs, etc. Right? For some things, for example, which is private, you want to use a model which is where you don't call an external API. Whereas for things that are anyway generally accessible to public, you might as well do it with an external API, and not worry about the scaling and the costs associated with that, right? Or having to run an infrastructure. So both this middleware and AI orchestration layer, that helps you separate out your GPU spend versus the regular CPU spend, right? So the regular CPU spend, you can do it in regular cloud kind of a scenario, but there is a certain aspects of it, especially the AI part, you want it to run on machines which have GPU, right? Of course, many of the clouds now provide these kind of machines, but you might also want to use this on your premise, right? You might want to set up a GPU machine, and you don't want too many people trying to access the GPU machine together and overload it, etc. Right? You want to utilize it effectively, and keeping the GPU machine running is also a cost. There's also cost associated with that, right? So you want to do that in an optimal way. So hence, we would recommend that we use a microservices architecture for this, for the entire thing, which is that you are not exposing the GPU system outside in the internet, but instead using pub/sub kind of a mechanism to make a request to run or execute an LLM task, or a task which requires a GPU, and then continue with the regular processing for the other parts of the software system, right? So this microservice architecture, it allows of much fine-grained control over the Gen AI models, where you can use multiple models together, use them in parallel, etc. But also it improves your time to market, so that it makes it easy for you to modularize your AI agents and your AI processes as against the traditional processes that you have in your enterprise. Yeah, so typical, as you said, a typical AI orchestration and a middleware approach. You will have your client, which is outside your system, and you have an API gateway, which would be where the clients would be able to send a request. Then that would be distributed to multiple microservices or services, and these services could be AI agents. They could be something like a microbot, which means that a microbot is basically a bot which can answer certain set of questions, right? Or cater to a certain use case, for example. Or it could be an agent which would take the input, process it, and then give a specified output and pass it on to a system, for example, right? You will need a model zoo, which means that you might have access to open API models, or you have access to closed models, or certain small models, or models deployed in your on your premise or different clouds, etc. Right? And then you would have a data pipeline, which means that all the data which you have from your enterprise that need to be passed on to these services as through APIs or through database collection connections, etc. They could also include your documents or your vector DBs, which are where you have your knowledge base, which is in your documents, and you want to convert that into a vector format. You might have a hierarchical knowledge graph, for example, for your enterprise, which will tell you how your products are categorized, what kind of commodities, or whatever categories that your products may be there, or even your process or your management, what kind of hierarchy it has. So there is a product, you can have a knowledge hierarchy, and then you could have your core APIs, right, which is basically your user, CRMs, ERPs, etc. Right. So all of this go into data pipeline, and this data pipeline is able to provide the information to your agents, your other services, AI-based services. That's how you would have a typical architecture. Right. So here is an example. So we have a product called GRYD, where we have implemented all these aspects of the AI agentic framework in a microservices architecture, which is fine-tuned for an enterprise deployment kind of scenario. Right. So which means that you can actually deploy it in a cloud of your choice. You can do it in a multi-clouded environment if you want, or you can do it under on your premise, parts of it on your premise, parts on a cloud, etc. Right? So the broad guidelines of that would be would be to have a model zoo, which means that you have cloud, so public facing stuff. You have some on-prem cloud. You also have things like domain specific models that you want to fine tune and keep. Right, you want to have sort of a database connections, which is like Postgres or MongoDB, etc. Right, and then you want to have hierarchical methods of governance. So you have a governance which is across the entire organization, and then you would have a product or a brand specific guidelines. For example, you would have specific process related guidelines, and then you would have the different prompts which you want to control for all your AI agents, etc. So our system brings it all under a single framework, where you are able to collate all these different pieces of varied information and then use it for your deployment. And of course, it goes without saying that we need to have a knowledge management portal which can process all the documents, create a knowledge graph if necessary, and store them in a vector DB, and also use them and also compile them in a way that it is accessible for all the different things. So you want your agents to actually answer from the knowledge database that you have in a fast and effective way, rather than from anything else that it was trained on, to reduce the amount of bias, reduce the amount of the mistakes it makes, and increase the accuracy of what it is trying to, what the output of your agents are, right? And then finally, there is the reinforcement learning part, where we have a system where we can give a certain percentage of the outputs of all your agents and your LLMs, etc., to actual human people, and incorporate their feedback into fine-tuning or tuning the outputs of these LLMs and the agents that we have deployed for an enterprise.